Hello people and welcome back to another video. In this video, we'll be picking up where we left last. In the last two lectures, we have covered normal distribution and standard normal distribution. In our previous session, if you remember, we left a problem midway. We understood the fundamental idea behind the problem, but we did not get the exact answer that the question was asking. We got a brief idea, but we didn't get to the exact answer. We'll be going back to that question in this video, but before that, we'll be looking at some of the programming commands in R that we use when we are analyzing normally distributed curves, or we are studying problems on standard normal distribution. So I would urge you all to brush up your concepts of normal distribution and standard normal distribution from the previous two lectures and only then watch this video. So there are four fundamental commands that we need to know when we are trying to understand and evaluate a problem on normal distribution. The four commands are dnorm, pnorm, qnorm, and rnorm. Now I will go over the utility of each of these functions in a little more detail. So we'll first look at dnorm. Now the general syntax over here, as you can see, is dnorm x. Mean is equal to 0 and SD is equal to 1. So mean here is the mean value and SD is standard deviation. By default, your mean and standard deviation are 0 and 1, which fundamentally is the case for standard normal distribution. But if you want to extrapolate this to normal distribution, you need to mention your mean and standard deviation of your normal curve. Going back to my text pad, first we are looking at dnorm. So the parameters that we give to dnorm is x, we give mu, which is mean, and we give standard deviation. These are the three parameters that we're giving to dnorm. What does dnorm give you? So when I give this value x, right here, this is any value x, which lies within the normal distribution. Dnorm of x gives the y value or the f of x value. So the formula that we studied in our lecture on normal distribution, which is this particular formula, dnorm takes the value of x and it returns f of x. As simple as that. We'll move to our next function, which is pnorm. In pnorm, the syntax is pretty much the same. We give q comma mean so basically what pnorm does, one easy way to remember this is p stands for probability, p stands for proportion. So pnorm gives you the proportion of values which lie towards the left of point q. So if this is my point q, what pnorm gives me is this proportion or this area, however you would like to call it. So it basically gives you the proportion towards the left of q. Now, if you want to find out the proportion to the right of q, there are two ways to do this. You can see this lower dot tail parameter set to true by default. So by default, your pnorm will give you your proportion towards the left. But if you put lower dot tail is equal to false, then it will give you towards the right. Else, the other way to do it without changing anything in the code is to find the area to the left and subtract it from the total area. So total area minus pnorm gives you the area on the right. Cool. This is what pnorm does. Now moving on to our final important function, which is qnorm. In qnorm, you give the p, you give mu, and you give standard deviation. Now qnorm does exactly the opposite of what pnorm does. In pnorm, your input is the point q, and pnorm will return you the area to the left hand side. In qnorm, I'm given this area P, and I have to find this point right here, which is point Q. So let me reiterate this very important point once again, as this will come in handy in later modules when we'll be looking at distributions, normal distributions in a little more detail, along with a few other distributions. This will be very handy. So P norm takes input as a point and it returns you the proportion of values which lie towards the left hand side of the point. Qnorm does exactly the opposite. It takes in the value of proportion towards the left and it returns you the point. Now, again, if you look at it, I'm emphasizing on the fact that the proportion is towards the left side of the point, not the right side towards the left side, because that is by default. If you want to calculate from the right, then there are two ways. A, you set the lower dot tail parameter is equal to false, or you subtract the area that is towards the left from the total area, you will get the area on the right. Please understand these fundamental concepts once again before proceeding further in this lecture. If you want, you can pause this video right now and rewatch it from the very beginning to this point. But if you've understood the concept, we'll move further and discuss a few questions. In the last session, we were discussing a question, but we did not fully complete the question. We got the basic idea, but we didn't arrive at the final answer. Today, we'll do that. This was the question. Let's assume that the birth weights of newborns are normally distributed with a mean of 3,500 and with a standard deviation of 500. What proportion of infants weigh less than 2,800 grams? Now remember, in the last session, I tried to analyze this problem from a standard normal distribution perspective. Now, because I am taking this problem from where I left the last time, I would actually like to cover this problem in both ways, normal distribution as well as standard normal distribution. Now, normal distribution, the idea is pretty simple. You have been given the mean, you have been given the standard deviation. This is where 2800 lies. Right? We need to calculate this area. So again, if you see, the proportion to the left of 2800 is something that we need to calculate. We'll be doing it using R. And from what I have just explained, it should intuitively come to you that because we have been given the point, what proportion of infants weigh less than 2800, and we need to find the proportion, we use P norm. 2800, my mean is given 3500, and my standard deviation is given 500. So this comes out to be 8.07%. If you multiply this by 100, you will get it in percentage. Else, you will get it in standard normal distribution format where the total area is 1 and you are basically seeing this proportion out of that 1. So we discussed in the previous session that the area has to be less than 16%. But we didn't get to the exact answer. The exact answer is 8.0756%. Now we'll solve the same problem using standard normal distribution. For the standard normal distribution, we just need to calculate the corresponding transformed Z value of 2800, which is 2800 minus 3500. Again, we get 1 minus 1.4. So you just put P norm of Z. That's it. By default, your mean is 0 and your standard deviation is 1. And you get the same answer. This again proves the fact that area under the curve and proportions do not change after standardization of a normally distributed curve. Now that this problem is done, we'll go to a few more examples. This will be an interesting example. Let's assume that the birth weights of newborns are normally distributed with a mean of 3,500 and the standard deviation of 500. What proportion of infants weigh between 3,250 grams and 3,750 grams? Now, I'll be telling you how to solve this question using normal distribution. But what I want you all to do is that before you see the solution, please pause this video and try this problem by yourself. Okay? And once you've tried it, you can follow along with me as I'm solving this question. Now, this is where you have, now your mean is 3,500. Okay? So this is where your mean is. So 3,250 will lie somewhere here. 3,750 will lie somewhere here. we need to find this area. The area that is shaded in yellow, this is what we need to find. Now, what we can do is that we know these 2 points. This right here is 3250, and this right here is 3750. Now, proportion behind 3250, which is this area, I'm marking it in blue. I can calculate this using P norm. P norm of 3250, comma mean, comma standard deviation. Now, the area or the proportion behind 3750, which I'll mark in pink, this can also be calculated using P norm. Now, if you see the proportion behind 3750, okay, I will do this. Is nothing but, if I call my desired area this as A1, this is nothing but A1 plus proportion less than 3250. So just you need to minus this from this to get A1. Let's do that right now in R. So your area or your proportion will be nothing but equal to P norm 3750, comma mean is equal to 3500. So you're getting an area of about 38.29%. So you can say that about 38.29% of the babies lie between 3250 and 3750. In the same way, I'm going to give you guys a problem to solve for yourself. Before we begin our next session, I'll actually be telling you how to solve this problem so that we can have a recap of this session in our next session. But I want you all to take down this question and try and solve this question on your own. And once you have solved this question, you can start watching the next session where I'll be taking up this question and I'll be continuing further with the remaining topics. But we'll end it for this session. I want to thank you all for watching, and I'll see all of you all in the next lecture. Thank you.